Okay, this section B and B1. Okay, Ivy is playing with a remote control. Right, short form is called the RC helicopter, and the specifications from the manufacturer are shown below. Okay, so the first part asks how many physical quantities are given in the specifications. So answer is 5 because okay, the 5 physical quantities are kilometer per hour, seconds, hertz, hour, and meters. And part B, okay, how many physical quantities in the specification have prefixes? And what are prefixes? Please refer to your textbook, page 6. Okay, prefixes refers to things like nano, micro, milli, centi, deci, mega, and giga. So how many physical quantities have prefixes? So we know that, okay, first one is the mega. Okay, second one, of course, is the kilometer. Okay, so kilo, mega are prefixes. Kilo is 10 to the power 3, mega is 10 to the power 6. And convert into standard form, 13.9 megahertz. Alright, by converting it, okay, mega is 10 to the power 6, but how come over here is 10 to the power of 7? So I'm going to show you why. 13.9 megahertz, okay, is equals to 13.9 times 10 to the power of 6 hertz. And if we move one decimal place in front, we will just write it as 1.39 times 10 to the power 7. Okay, and is the maximum speed given in the above specification a scalar or a vector quantity? Okay, the maximum speed given is a scalar because it only has magnitude but does not have direction. For question B3, a metal can has polished surfaces. A similar can has its surfaces painted black. Alright, okay, so there are two cans, can A and can B. So this one is a polished surface and this one is painted black. Alright, the figure below shows how the temperature of each can varies over a short period of time after they are moved into strong sunlight. And okay, for part A, what is the name given to the process by which energy reaches the can from the sun? Okay, we know that between the sun and the earth, okay, is vacuum, and the only way where heat can be transferred is through radiation, because radiation, we do not need a medium for the heat to get transferred. Okay, and part B, which component of the sun's electromagnetic spectrum produces the greatest heating effect? Okay, it's called infrared this effect, and over here is for your info. Alright, so which can A or B is the one painted black, and give a reason for your answer. For this part, you have to refer back to the graph. Okay, so which can is painted black? Okay, so let's take a look at the graph. Graph A, okay, for can A is higher than graph B. Okay, what does this mean? So your skill reading, okay, graph reading skill has to come into place. And okay, let me explain to you how this is read. Okay, this is red. And okay, over here, let's take a look at this time axis. Okay, imagine both cans are heated for 10 seconds. Okay, now the temperature one would be here. This for can B. The other one will be over here. Okay, so which has a higher temperature after heating for 10 seconds? Okay, is can A. So the temperature reading here would be higher than the temperature reading here. Okay, so can A is obviously heated up much faster than can B. So the answer over here, can A is painted black. Okay, why? Black surface is a better absorber of energy. Okay, this one you have learned it. Then polished surfaces, hence it can quickly absorb heat. For B4, one end of a copper bar and one end of an iron bar of the same size were placed side by side in a fire. Right? A, the heated end of the iron bar becomes red hot. The heated end of the copper bar did not become red hot. what can be deduced from this observation? Okay, this one, okay, I just want you to read it for yourself. Okay, it's rather common sense and it's rather easy. Okay, so for part B, same thing. Okay, read it for yourself. And now, okay, let's move on. For B5, the diagram below shows how the temperature of liquid substance Z in a beaker changed as it was heated continuously for some time. Okay, so the first question, what was the boiling point of the substance Z? So again, okay, boiling point, we know that the temperature remains constant, and the constant temperature is 80 degrees Celsius. So we just write it down, 80 degrees Celsius. For part B, explain why does the temperature during boiling process remains constant despite continuous heating. Okay, this is the explanation that you have to make. Thermal energy from heating is used to break the forces between particles. Alright, so the keywords here are used to break the forces between particles. If I see this, okay, I'll give you 1 mark. Instead of changing into kinetic energy of particles, or you can say that the kinetic energy does not increase um, during the boiling. Okay, so if I see this kinetic energy does not change, or instead of changing, I will give you another mark. Alright, so from 4 minutes onwards, what is the state of substance Z? Okay, from 4 minutes onwards, so let's refer back to the graph. 4 minutes, okay, so 4 minutes over here. 4 minutes onwards, okay, what is the state? Okay, do not make the mistake saying that, okay, it's only gas. Okay, because over here substance Z is still undergoing boiling, so it's a mixture of liquid and gas, right? For question B6, okay, this is something that you have learned in chemistry, so I'm not going to go through this. It's about evaporation. Okay, and write down 2 differences between boiling and evaporation. Okay, this is rather easy and straightforward, and please refer to the textbook if you do not know the question. For B7, the diagram shows a coil or spring along which a longitudinal wave is moving. So take note of the keyword once again, underline them. Okay, shows a coil or spring, and this is a longitudinal. Okay, please take note, this is not a transverse wave. Okay, this is a longitudinal wave. Okay, explain longitudinal wave. Okay, this explanation you can look up once again in the textbook. Keyword here is parallel, okay, to the direction of the wave motion. Okay, particle move in the direction parallel. Okay, and for part B, define wavelength. This one again, okay, is definition. Simply just to recall, okay, what we have learned in during the lesson. Okay, now I want to move on to part C. Okay, there's a phone coming in. Okay, for part C, mark on the diagram above a distance equal to the wavelength of the wave, and label the diagram with a letter C where the coils of the spring are compressed. Okay, over here I know that you might not have learned this before, how to find a wavelength in a longitudinal wave. Okay, but don't worry, okay, just observe the wave over here. Okay, there are regions of compression. You see the springs, regions where they are closer together compared to the regions over here. Okay, so these regions are a bit closer. So we label C directly above the region of compression. Okay, so this is the region of compression. This is the region of compression. Okay, so you can label anywhere that's above the region of compression. So this can be C. Alright. So how do we know where the wavelength is? So the wavelength is quite simple. Okay, it's just between 2 regions of compression. So